Good day, viewers. In today's lesson, we'll be looking at another types of set. Remember that my last video was based on universal set and segregating set. So today we'll be taking another types of what set. The first on the list here is the null or the empty set. Now the question here is, what is null or empty set? These are sets which contains no element, or it is the subset of every set. Let's consider an example here. Given says, okay, before that, it is denoted by this sign or just simply an empty word bracket. So let us consider an example. Given set W is equals to a curly bracket Y such that Y is a set of JSS1 students who is a principal. Now, if you look at this statement very well, Y is a set of JS1 students who is a principal. Of course, you can't expect JS1 student to be a principal of a school. So that means the final result of this set is simply what? Empty. Okay, so the answer here is simply going to be what? An empty set. This is an empty set. Okay, so now, but I want to get you to take note of something here. Let me give an example. Let me give an illustration of what I'm saying. So look at, let's say we have a set J is having 0 as its element. Now this set J now will not be regarded as null or empty set because it is having an element, and 0 is an element here. But when you have an empty bracket like this, or you have this sign, it's simply called what? Empty set. Like this one now, a set of J, one can never be a principal, so it is empty. So, but when you have J, for example, element J or set J equals to 0 as it is, this is not an empty set. So note this, note it, because 0 is what? Is an element. So let's take the second types. Okay. The second type is known as the subset. What is subset? Subset is the child or children of a given universal set. Subset is the child or children of a given universal set, and it is denoted by this or simply this. You can denote a subset with this sign or simply this sign. So let us consider an example here too. Given universal sets A, B, C, D, and E, and we have the subset A to be A, B, C, and we have subset B to be A, K, C, D. Now, if you look at these two subsets of this universal set here, it is only this one that contains this element, but this does not contain this element. So if I want to interpret this one, I can simply say A is a subset of the universal set, or I can write it like this: A is a subset of the universal set. So either this or this is allowed. But if I'm to take U now as the first letter here, so I will say U, that's universal set, that's the opposite of that subset. So we don't call it, you don't call this now, you don't call it subset, you call it contains. So that means U contains A. Or I can write it like this too: U contains what? A. So this is U contains in A, and this is A is a subset of what? Of U, which is universal what? Set. Okay, but if I'm to interpret this one now, it is not universal, it is not a subset of the universal set. So what I'm going to call this now, I'm going to call it B is not a subset of U, or I can write it like this: B is not of U. So also the universal set does not contain B. So that means I will write it like this: or in what? B. So that is all. So please hope you guys understand this. So if you have any question to ask, kindly drop in the comment section. So I will stop here for today. But if you have not subscribed to this channel, please kindly subscribe to this channel to get updates of my coming videos. I'll see you guys in my next class. And don't forget, like this video and share this video. Bye for now.